Okay, it's time for the Weekly Space Hangout. I'm Fraser Cain, publisher of Universe Today, and this week we're going to be talking about SpaceX, the progress, the crashed progress. We're going to be talking about life in Enceladus, NASA's warp drive, and comets coming this summer. But we've also got some special guests, so we'll get to that at the end. First, I'd like to say hi to Dr. Brian Koberlein.
Hi, thank you very much.
We got Charles Black from Sendcom. Hey, Charles.
Hi, Fraser.
We got Dave Dickinson.
Hey, camping out in my house in Florida.
This is what it's like to live in a house and come back to that house on a regular basis.
And try to sell it again.
And we've added a new space journalist to the mix, which is Jolene Creighton from Quarks to Quasars. From Quarks to Quasars.
Yes, it's a tongue twister.
Yeah,
so.
from. Hey, Jolene. Welcome to your first trial by fire of joining the Weekly Space Hangout. I promise that it will be really difficult, and so.
There's gonna be a quiz after.
But try to have fun.
Okay, I'll try.
And this week we've got some special guests, which is Brian and Emily from Astronomy on Tap. Although these are not the names that I was expecting when I looked at the show rundown. So
we don't know who Brian and Emily are. We're
Nope.
kind of concerned that they're trying to steal our identities. Frankly, like we hear their names everywhere.
I have
They're
sent
like
credit card charges too. I don't know what's
super
going
creepy stalkers.
on. Yeah.
I don't know.
So they're our special guests, and we'll talk to them in 1 second. But before we do, I just want to remind everybody that this is a live, interactive program. You can talk to us, and the way to do that, the recommended way, is to use the Q&A app, which is wherever you're watching this video, anywhere on YouTube. You should be able to click the link, click that link, and then you'll see sort of a list of questions and comments that are being made on the side. But you can also still watch the video, so it's very convenient. And just to demonstrate that this is actually happening, I'm going to say hi to Stephen Hawkins, Jim Meeker, William Hutchins, Nancy Graziano, Matt Woods, Jason Carlson, Guido Bibra, Tom Van Scotter, Ignatiy Romanov Cheregovsky, Seb Despbunny, Lionel Ward. Wow, everybody's here. Richard Strassel, Tom Nathy, Bob Harkins, Michael Jobin, man, everybody. And Nancy Graziano, if I didn't already, who is sort of one of our producers. So, well, let's get on. So, Tycho and Carly, can you please explain to us what Astronomy on Tap is, for anyone who doesn't know?
I like to say that it's exactly what it does on the tin. It does exactly what it says on the tin. I screwed up every single time.
What tin?
Yeah,
there's no. Take another crack?
It does what it says on the bottle. Maybe I should change that. We're still working on our slogans, obviously. Well, our best slogan is actually straight from the lips of Neil deGrasse Tyson, and it is "Drink in the Universe." So what we do is we talk about astronomy at bars.
While drinking.
While drinking.
Wow.
Drinking is optional. We're not drinking today. We have an awful lot of work to do. But we go into bars and we talk about astronomy. And we kind of have a little bit of a format which tries to keep it kind of short and interesting, engaging, very, very interactive. But we are the organizers of the New York City events, which is where it kind of took off, although it actually started in New Haven, which is a little bit of a story. But now it's spreading all over the world, which is actually very exciting. And each location, we call them satellite locations. And each location kind of has their own take on things and does things their own way, which is super fun.
But we try to bring professional astronomers and astronomy educators and science. Yeah, they get paid to do astronomy. That's close enough. And we try to bring them to the public and make astronomy accessible for everyone who attends our events.
So, let's say I don't live in New York City, which I don't. I live on an island in Canada. But let's say I was to attend one of your events. Where do you normally do them? How big does it happen? How does it go for the night?
It varies. So in New York, our events tend to be between about 50 or 60 people. We do them usually on a weeknight. Thursday nights is kind of our big night, and they're usually in the evening, maybe 7 to 9 or something like that, so that we can get the tail end of happy hour and also make sure that people can get to bed relatively early. And when you walk into the bar, you might at first not notice that anything's going on.
It depends on the bar and if they have a back room or not.
Yeah, but except for possibly people walking around with glittery things on their head, bright orange hair, something like that. But we usually have a screen set up, so we do use kind of traditional PowerPoints or let people show videos and things like that. But we usually have a music running that's astronomy-themed, space-themed music at the beginning, hence DJ Carly Sagan. I take that very seriously. And then we have usually a slideshow game running at the beginning. And so something like we've had Game of Galaxies, where we show a picture of a galaxy and you have to match the picture with the kind of common apod name for the galaxy. So Pinwheel Galaxy or Sunflower Galaxy, Mice Galaxies, things like that.
Some pop culture stuff like, is this sci-fi or has this actually happened? Like, and flashing pictures of hoverboards or warp drive, things like that. And then at the end of the night, we collect all those all the question sheets and we hand out prizes to people that win.
And share all the answers, yeah. And then in between, we have speakers. So we usually have from 2 to sometimes even 5 or 6 speakers, depending on if we have like an epic night, and we've had some longer events. But usually we have around 3 or 4 presenters, and they do a 5 or 10 minute presentation about either their research or some other topic that they're interested in, or something that's been in the news or something like that. And we have lots of times for questions from the audience.
And Carly and I tend to heckle them a little bit, or
maybe
It sounds like it's a good companion to doing some sidewalk astronomy, right? Set up some telescopes outside, and then if they just avoid you, then you can chase them right into the pub and bring the astronomy to them.
They think that they're getting away by going into the pub. Yeah, and sometimes we do have. Sometimes we have amateur astronomers from the New York Amateur Astronomical Society, the AAA, but the different AAA. And we have our own in particular. Her name is Brooklyn's Friendly Neighborhood Astronomer, and she has Brooklyn's prettiest telescope. That's a telescope that she actually made herself and decorated with stars that she takes mostly around Brooklyn, sometimes into Manhattan and other places. But she's at a lot of our events, which is super fantastic. And so we do sometimes have the observational. That's a little bit harder in New York City, but not as hard as people might think to be able to see some cool stuff.
Especially when Manhattan Henge is going on.
Oh yeah,
line
that's
up
also
perfectly.
a big one. Yeah.
Yeah.
Last year was Moonhattan Henge too. That was exciting.
Oh, right.
So the full moon was rising during Manhattan Henge, and so you had Moonhattan Henge on the other side, which is also very rare. I haven't figured out exactly how rare it is, but it's pretty rare.
I can talk to
And
you
we
about
did
that one.
have a couple. I think 2 times we had Jackie Faherty, who I like to call the mistress of Manhattan Henge, because Neil kind of Neil, like first name basis, Neil Tyson kind of started it, and several years ago now. But he doesn't really do necessarily any programming with it. But at the Museum of Natural History, there's a live program now, and Dr. Jackie Faherty runs that. And so a couple times we've had her do kind of a preview in the history of Manhattan Henge at Astronomy on Tap a week or 2 before she actually does it at the Museum of Natural History. And so that's sometimes we get the inside scoop and stuff like that.
I can claim one of the only Manhattan Henge sunrise pictures that's out there too.
Oh yeah, I am never going to do that.
Way too early in December or early January.
Unless I stay up, that is not going to happen.
So, and you said that you've got a bunch of satellite events happening now.
Yeah. All over the place. So let's see.
Rochester.
Rochester's new. Baltimore's going to start.
Denver
Those 2 are started. Going to start in May. Denver just started in April. If we go back from the first ones, so like I said, we started in New Haven. It was actually the brainchild of Meg Schwam, who was an astronomer. She was a postdoc at Yale, and she had done a couple events in New Haven that she's called Astronomy Uncorked, because she's a wine person and she had them at wine bars. And she, when she decided to bring it to New York City, I kind of helped out at the first one, and I said, I really think you should broaden this a little bit and call it Astronomy on Tap, and we'll do it at bars, because kind of bars in general are more common than kind of wine bars. And so she kind of rebranded it Astronomy on Tap and did it the first time in April 2013. And then we kind of co-organized for a little while, and then she got a postdoc in Taiwan, and so she moved on to Taiwan. But we continued doing pretty regular events pretty much since then. Yeah. And now, so they've gone back to New Haven. So now there's a person that's organizing them in New Haven every couple months. There's also events in Columbus, Ohio. Those were kind of our original satellite events, because they were people that had participated in New York City that went off to Ohio. Ohio is Dimitri Muna, who's there. And then people started to hear about it and wanted to start it in locations where they already were. And so Toronto has started one that's run by the Dunlap Institute. Austin, Texas has one that's run by a couple postdocs at UT Austin. What else? Santiago has one that's run by an ESO outreach person. Denver has one that just started. I'm forgetting somebody in there. They'll kill me. Oh, Seattle just had one started. So we did a poster at the AAS meeting a couple years ago. It must have been 2014, and that got a lot of interest. But it takes, sometimes it takes a little bit of a spark or something like that to get things started. And so slowly but surely we're building up the number of locations.
Well, I think about it, when I'm at the pub with my friends, and I will start an impromptu Astronomy on Tap, just by the kinds of things that I want to talk about, and they
that's kind of what we found. If somebody finds out, and then you're stuck to somebody like explaining black holes to somebody, and it's like, oh, why can't I put this on my CV? Yeah. And so basically, like one of my jokes is that sometimes our drinking was our science was getting in the way of our drinking, and so we decided to do something about that, and this is our solution to that problem.
But I think it gives all those people an outlet, right? All the people who just want to share all the stuff that's happening in space while they're at the pub with all their friends. Just legitimize it. Just join with Astronomy on Tap, and then other people will show up as well.
We are only one of, I don't want to promote other people's organizations too much, but we are only one of many kind of organizations that are in talking with people and doing kind of these public low pressure events that are based around science.
Ours is the best, though.
Yeah, so. Ours is a little more themed and a little more fun maybe than some of the other ones. But they're all meant to really engage the public, and there's a huge kind of interest in science right now, and we're kind of playing on that. And enjoying the fuck out of it.
Bleep, bleep, bleep.
It's the internet.
Okay.
So David, you've done the math on moon hat.
I just did a back of the envelope. I was thinking about it, and I think a moonrise with each Manhattan hinge, assuming that it's fixed with the Gregorian calendar on a date, it should be once every 19-year Mentonic cycle, I think. That's without doing much research.
What do you mean fixed on a date? If Manhattan Henge is fixed on a date every year?
I think it's fixed where it happens. It happens near the solstice or the equinox, I believe. I'd have to look that up, but
it's on either side of the solstice.
Yeah.
Okay. But if it's fixed in every Metonic cycle, the phase of the moon repeats again, like on that same calendar day. So I think it would be once every 19-year cycle. Sounds pretty rare.
Shit.
I dare anybody to prove me wrong.
I made a deal out of it last year. Now I'm just kind of pissed.
We just have to keep Astronomy on Tap running
for another night. Oh,
19
right.
Years.
God.
Yeah.
Oh.
It was like what we did with the transit of Venus.
Oh, that's even better.
We that was our practice, the one in 2012, and then on the next one we'll really get it right.
2117.
Yeah, in our robot bodies.
We'll have heads. Our heads will be in jars by then. So.
Yeah. Exactly. So let's say that I want to start a Astronomy on Tap here on Vancouver Island. What do I do? Or anywhere in the world.
Yeah.
I think the hardest part is finding a good venue, honestly. And so what you've got to do is put in the time to go to all those bars, have a few drinks, check out the sound system, check out the AV system. It's terrible.
And
I like this part already. Yeah.
The Austin people at one point, so they're on their third venue now because their crowds were getting so big, and I think trying to find their third venue, they went to a couple dozen places to try to find a new venue. Yeah, they said it on Facebook, whatever it was.
Yeah, you could do that nonstop in Austin and never to the same bar.
You barely
right. Okay. And then what about contacting you folks? What's the way to sort of connect into the larger hive mind?
Yeah.
You can
astronomyontap@gmail.com.
Yeah, or on Twitter, Astronomy on Tap, or on Facebook, Astronomy on Tap. I think the Denver guy came to one of our events here and then contacted us and is now running his own shows. And
it's usually astronomers that start them, but we kind of had a new precedent with Denver where it was just a guy that was visiting and came to one of our events in New York City, and he said, I want to do this in Denver. And I knew there was a bunch of astronomers in Denver. He's not a scientist at all. He's like a financial planner, and he books music events kind of in his spare time. And so, at the event I said, oh yeah, send me an email thinking, how many people actually follow up. Very few people follow up. He followed up, it turns out that he and I have like very similar tastes in music, and so even though I didn't really know this guy, I kind of gave him the benefit of the doubt because I figure anybody with such phenomenal taste in music as I have has got to be good. And he did it, and so I kind of helped him find the astronomers, and they had 3 astronomers present last time. They're going to go to a new venue. He's going to get free kegs of beer, which I think is fairly impressive, because they did it at kind of a DIY space, and the next one might be at an art gallery, I think. And so it's kind of however you can make it work, as long as you're making it work, that kind of works. I think the one mandatory thing we have is the glow sticks. That's required for every single event.
And you get glow sticks for asking questions if you're an audience member. I would say another requirement is it's supposed to be fun.
Yeah, okay, yeah, that's very rarely do we actually have to enforce that one.
But it's not just supposed to be like an hour-long lecture from one person in front of an audience with a very formal Q&A session. We want people to ask questions in the middle. We don't want to interrupt people that are at the bar also drinking and just enjoying themselves. So we're not like enforcing a quiet environment for everyone to be in.
So for anyone who does live in the New York City area, when is your next one?
May 21st.
Good job. I totally knew that.
Yep. May 21st, we're up at Silvana in Harlem, and actually bouncing back off to one of your previous questions, we in New York City, we have the luxury of being able to bounce around to a couple of different bars. And this is the first time we'll be at Silvana, and we're trying it out, and we hope people will come out. May 21st, I think we're running 6 to 9 p.m. The details we'll add some more details to the website soon, because we just confirmed a couple more of the speakers this morning, and
totally super far in advance, way ahead of time.
Yeah,
we're totally cool with this, yeah.
And for people that are interested in putting their own on, we're coming up with kind of training documents or kind of things that we can hand out to people who are interested, kind of more on the technical side. So you don't need to read this unless you're really trying to set something up. We're not ready yet. Well, we'll get there soon.
We're working on it. We already, I have a shared Spotify playlist, actually, that anybody can actually find and contribute to. It's just DJ Carly Sagan on Spotify is the username, and then I have an astronomy-themed playlist, which I actually started only in January of 2015, and then I opened it up to astronomers at a conference, and it's now at 50 hours of music or something like that, all space and astronomy-themed music, yeah, and all kinds of different, I had my own playlist, but it's skewed towards my musical interests, and so I opened it up, and man, it went crazy. It's super, super awesome, and so you can just play from that. You can make playlists, I think, from that for your own event. We have a bunch of games that we've already made, like the slideshow games. We have bingo that we sometimes make, so we have bingo templates for people to play during the games.
We've been running kind of 2 series at once. We have our multiple speakers come, but we also are running once a month a Cosmos on Tap series, where we screen an episode of Cosmos. We have one special guest speaker besides the 2 of us, who's kind of an expert on that episode's content. And all those games are kind of related to that particular episode, so people could easily. We're just running it off of Netflix, and since we're not charging, I think it's legal.
It probably isn't if you're doing it.
For educational purposes.
For educational purposes, yeah. Awesome. All right, cool. Well, if people want to find out more and reach out to you, you've got your website address there, and I guess everything is the same. At gmail.com, on Twitter,
Facebook, Twitter, Instagram,
and the website.
And this tattoo. Oh no, I don't have a tattoo yet. Damn it.
Damn.
Give it a couple more years before you commit to the tattoo.
Pins. I didn't bring my pins.
Oh yeah, we have pins. We take donations. We're doing this all on our free time. And in fact, yeah.
If anyone from NSF is listening,
This fulfills your outreach credit.
Yeah, totally.
Awesome. All right, well, thanks, guys. Thanks for joining us, and keep us posted. And anyone who's ever in New York City, look them up and join an Astronomy on Tap. I know I would love to. So maybe we'll see you in New York City sometime.
Thank you.
Thanks
for having us.
Thanks, guys.
Bye.
All right, let's move on to the news. So, Jolene, we'll let you go last, so you can sort of watch and see how everybody goes before you, and then we will put you on the spot.
Okay.
We'll start with. I'm going to start with Brian Koberlein because I'm super excited about what he put into the docket. So, Brian Koberlein, let's talk about NASA's functioning warp drive.
Oh yeah, the functioning warp drive that has no published papers on it. Yeah, that's a good one. Uh, Basically, this hit the press, I think, largely because if you put NASA and warp drive in a headline, it is link bait gold.
I know this to be true.
Yes. So it shows up every now and then. The reason it showed up recently is because about a year ago, the EM drive folks had done an experiment where they had said that they had found, running this machine, which basically oscillates electromagnetic waves in a chamber, that they were finding a thrust from it of about 50 micronewtons. So I think I did a rough calculation. It's basically the weight of a snowflake, is what you're talking about. And of course, this was done in standard atmosphere, and so one of the first things you would look at is there something with either heating and you're getting some thrust off of the air, or some electric discharge that would get the same type of thrust. So the next step was to do it in a vacuum. Well, they recently apparently did it in a vacuum and got a similar insignificant thrust. But it's not zero, and so this caused a lot of brouhaha in some of the unofficial discussion groups that deal with NASA research and NASA technology stuff. And so the press picked this up, and it went ballistic.
Right. So can we sort of explain how the EM drive theoretically works?
Well, theoretically, you've got some type of chamber in which you can contain electromagnetic waves. And you bounce these electromagnetic waves in this chamber, and then you get a net thrust without a propellant, and that's the big thing that makes it very controversial, is that you're getting a thrust, but you're not throwing anything out the back end.
So, for example, for a practical application of this, then you might have a spacecraft with solar panels, and then it is converting the electricity from the solar panels into electromagnetic radiation, which is perfectly fine, and then it is essentially pointing the electromagnetic radiation out the back, and that's acting like a thrust.
No, it's not doing it with electromagnetic radiation. That's the key. If it were just throwing light out the back end, then that's not a big deal. It may not be very powerful, but you could easily, for example, use solar powers to create a laser and then shine a laser out the back end of your rocket, and you get a thrust because the laser beam has momentum.
Yeah, well, that's... Oh, so it's different than that. Okay.
It's different than that because it's contained. So it's not. From what we could tell, it wouldn't be. It would be violating Newton's third law. So it's not just shining light out the back end.
So it is contained in that it's staying in some kind of containment facility, and so nothing is getting out, and yet it is able to move the spacecraft.
That's the idea.
And also, does it somehow generate energy by Newton spinning in his grave?
Yeah, I think so. I mean, they have some ideas in terms of maybe it interacts with the quantum fluctuations that are in the background, and there's some reaction off of that.
Because you just sound like Deepak Chopra there.
It does. It does. And the other one was that apparently, all of this is coming from discussion groups. So apparently, some of the people looked at an interference pattern near the device, and they were basically looking at, was there any warping of space and time? And according to the discussion groups, it is consistent with the Astronomy warp drive. It's not clear what they mean by consistent with, but that's what's being.
It matches with. It's in line with the predictions made by. Is this a difficult concept?
It's equally imaginary.
It's equally imaginary.
No, they don't. What's not clear is what do they mean by how is the interference pattern shift. So
how is this a warp drive?
Well, if their interference pattern was actually measuring a warp of space and time, then that would be another way to explain how you're getting thrust, because you would be doing some weird asymmetrical warping of space and time that would give it a thrust, kind of like the warp drive idea. Basically what it comes down to is they're trying to do this device. They seem to be, and I'll say seem to be, getting some very, very tiny thrust that they can't explain. Whether that's some new effect or whether it's more likely to be something they haven't pinned down is something that's still being worked out. The big thing is that they don't have any published peer review, so they haven't done any peer review studies yet of this. So it's hard to pin down the details.
And that's super weird for NASA because they're generally completely out in the public with everything that they, all the research that they do. They go through a pretty long process. They publish a lot of other stuff to AstroPH.
Yeah, and the thing is, I think, they haven't published it yet. So I suspect that what they're doing is, given that if they're right, they're probably doing some either weird thing of violating Newton's third law of momentum, or they're doing some weird quantum coupling thing that they don't understand. So they're going to work on trying to pin down if it's from a known source before they start publishing this, because that's the first thing everyone's going to look at. So I don't think it's too unusual that they haven't published it yet, but the buzz is coming from the discussion groups.
Right. Okay, so then, you've sort of explained the underlying technology and how it's, could it scale up? If it's the power of a snowflake, could that eventually get you to faster than the speed of light if what it's doing is warping space?
It would depend on whether they're doing some type of push thrust or whether they're doing warping space. The warp drive idea that was published in Classical and Quantum Gravity, that used exotic material to get faster than light warp drive. If it's just a thrust, even if it were just a thrust, you would be able to continually push out this thrust, kind of like a plasma ion drive, but without a propellant. So even if it were just that, you wouldn't go faster than light, but you would go at some interesting speed. I have no idea if they can scale it up. Again, all of this is rumor and speculation. They think they can scale it up. They have to bring it to the table that it truly exists first.
But now that people should be able to start following in their footsteps at this point.
Yeah, if they're publishing the stuff, we're either going to know or we're not going to know.
Yeah.
So we'll hear about this again, I guarantee you.
I'll work it into my next sci-fi story.
There you go.
There you go. Awesome. All right. Cool. Well, I'm excited. See, I'm not a total curmudgeon about all of this new space technology and warp drives and stuff. This could work. I'm stoked. All right, Charles. Let's talk about the SpaceX Dragon and the test fire they did.
Yeah, so SpaceX did what's called a pad abort test this week. It was a Dragon capsule that's been developed to carry crew to the International Space Station in low Earth orbit, and they've been developing that for a while. And this was the first test. It was unmanned, and they just fired the capsule with these super Draco thrusters. And the idea is it's like an ejector seat, so that when the Dragon capsule is on top of the Falcon 9 rocket launcher, if there was an issue with the rocket during the launch, this capsule carrying the astronauts would be able to fire off and then parachute to safety. So it was quite an interesting test that all seemed to go according to plan. And there's another unmanned test in the summer, and they're eventually working towards a human flight with a NASA astronaut and a SpaceX astronaut in 2017. The idea being longer term that they'll be able to get a contract to take astronauts to and from the space station.
And this is one of the big requirements, right, for being able to be human rated, is that you've got to have some way to get the astronauts off the pad to safety if there's some problem with the rocket itself. And when you look at the old Apollo missions, they had some kind of a rocket that sits at the top that would sort of boost them away. So in this case, the capsule can take them to safety?
So the capsule itself, rather than, as you say, like the Apollos that have the rocket on top of the capsule to pull the capsule out of the way, this is using these Super Draco thrusters that SpaceX have been developing. But what's interesting about these thrusters is that they're also designed to enable the vehicle to actually propulsively land for example, on an asteroid or Mars eventually. So they're not just going to be used as the launch escape system. These thrusters have another purpose, which is actually to enable the whole capsule to be able to land on a celestial body somewhere in the solar system in the distant future. So quite interesting to see that. I think it went from 0 to 100 miles an hour in sort of a couple of seconds. So it's pretty quick, and it looked like quite a rocky ride actually.
That would be pretty terrifying.
It was kind of fun to watch. That was actually more interesting than a usual rocket launch, I thought.
Yeah, it was, and I saw there was a video of Chris Hadfield having breakfast, eating his Cheerios, watching it, and he sort of just watched it and went, "That looks like quite a wild ride."
He mentioned, Chris Hadfield mentioned something I didn't know. The Russians are the only ones that have actually done a pad abort during one of the Salyut missions back in the 80s. I looked it up. I was like, no way. So there have been human beings. They did like 17 Gs when they ejected, but they actually did have to use it for real.
This is one of the problems with the space shuttle program, was they didn't have a really good pad abort system apart from, I think, some kind of like they had like a zip line they could get out of the shuttle or something, but they really didn't have a nice, safe way to get them off the rocket if something bad was happening. That's
right. Yeah, they did make a modification after the Challenger disaster, but it's a key requirement, as you say, for this and Boeing's CST-100, which has also been developed to carry crew to the space station. So, but it's also the story is interesting as well because it links really with the Progress Russian cargo disaster really that's happened over the last few days. So if I can link to that, this is a Russian supply ship for the space station. It's been doing it for many years, and it launched on April the 28th on top of a Soyuz 2-1A rocket. And there was an issue basically pretty much straight after launch, and the issue actually happened in a 3-second window between when the command was issued to the third stage of the rocket and between that and the Progress spacecraft carrying the cargo to separate. There's a small window. So the main issue was that essentially the Progress spacecraft wasn't able to get into the right orbit and therefore couldn't rendezvous with the space station where it's meant to be taking some supplies, and gradually they lost control of the spacecraft. I'm sure lots of people have seen the video of it spinning and so forth. So eventually that landed back in the Pacific Ocean, whatever was left of it after burning up through the atmosphere in the early hours of this morning, about 2 a.m. UTC. The significance of it, though, I suppose, is that it launched on a Soyuz 2-1A rocket. Now, the crew launch on a Soyuz FG. It's a slightly older Soyuz rocket, but they think, although they haven't defined the actual cause of the accident, but they think it was the third stage of the Soyuz, and it has a lot of the launch mechanics of the Soyuz that carries the crew is the same as this Soyuz. So what they've said is they're going to actually put on hold this the launch of the next crew, which was the TMA 17M, meant to launch on May the 26th, carrying 3 new crew to the space station. That's now on hold whilst they investigate what happened with this. Was it the actual problem with the Progress spacecraft, or was it the Soyuz third stage? But it shows that spaceflight is never routine. There was a problem with the Progress that fell back to Earth back in August 2011. We saw last October the Orbital Sciences had a problem with their Antares rocket, which was carrying the Cygnus spacecraft to carry cargo as well to the space station. So spaceflight is not routine, and we're only left now. We've got SpaceX's Dragon that so far has been successful carrying cargo to the space station. We've got Japan's HTV, which is due to have its 5th mission later this year. But recently the European ATV retired. That was the 5th and final ATV, which was an automated transfer vehicle, again another cargo ship. So we're not left with a huge amount of spacecraft that can reliably ferry cargo to and from the station, and probably equally significantly, we've only got the Soyuz that can carry crew to and from the space station at the moment. So the need for these new commercial spacecraft from SpaceX, the Dragon, and from Boeing, the CST-100, is obviously, has really been brought into focus by this disaster of a cargo ship.
Yeah, it's very good timing for SpaceX to do their pad abort test for the Dragon capsule, because that's going to be their human-rated spacecraft to get up to the space station. And I'm sure the pressure is on, for Musk and team to get the system rolling and use it to get crew up there. It's so weird. Here we are just a couple of years ago when everyone was just laughing hysterically at Elon Musk's attempts to start a rocket company, and now here we are just a couple of years later with more and more of the entire U.S. Space launch infrastructure depending and putting its hopes and dreams on what happens with SpaceX. So
I thought it was ironic, Charles, that the Progress re-entered over the South Pacific anyways on its own. But that's where they usually re-enter when they do controlled re-entry. It's like it knew it had to re-enter over the South Pacific.
Right. It just wasn't filled with garbage and leftover stuff.
But that's so boring. Nobody got to see it.
Yeah.
But the crew on board the space station, they've got supplies for several months in terms of food. They've just got a new espresso coffee machine on board.
Yeah, that's all that matters.
They've got their HD cinema screen now, so they're okay for now. But obviously, there would have been a lot of fresh food and fruit and things on board, which they'll miss. But it's a bit worrying. It's worrying if they, how long is it going to take them to find what was the cause and then to fix it? And these things take a long time.
Yeah.
So
we'll have to see what happens, and if it does actually cause a delay to some of the launches coming down the road, especially some of the human-rated stuff, which I guess may be depending on the same upper stage. So that's trouble. Dave Dickinson, let's talk about some comets.
Yeah, there's two comets that are binocular comets that have some pretty good potentials for the coming months here, mostly for the southern hemisphere, but we may get a look at a couple of them come July from the southern U.S. and southern Europe, from mid-latitudes or so. One of them, Q1 Pan-STARRS, we've known about for about a year. It was discovered by the Pan-STARRS survey in Hawaii that looks for near-Earth objects and comets last August. That one is in the morning sky right now. It's about 10th magnitude, which is right knocking on the range of binocular versus telescope observability. I have not looked at this one yet. This one, it's going to reach perihelion in early July, and then it should get around. They're projecting about 2nd or 3rd magnitude. Now, comets don't always perform the way they're supposed to, as we all remember from Comet Ison, how it didn't perform how we wanted it to. But this one, if it matches projections, we may see it in the evening sky here from mid-latitudes in late July as the 2nd or 3rd magnitude comet. However, if you remember L4 Pan-STARRS, this one's going to do the same thing, where it's going to be going parallel to the horizon from our field of view, and it's going to be beyond the sun. So it's never going to get out of that twilight region, unfortunately. So it's always going to be against a low-contrast sky. But if it gets bright enough, we may be able to see it with binoculars. It probably won't do what Q2 Lovejoy did, where it went right up against the dark sky this past winter, and we got a lot of good photos, and everybody got to look at it, and it was naked eye, a faint naked eye comet, but it was still pretty bright. The second one that's coming up, G2 Master, that was just discovered last month. This one's another one it's already at 7th magnitude, and I'm going to try to share a photo of it here, because a friend of mine down the southern hemisphere, this is the same one we ran in the article. I'm going to try not to break the Google Hangout here by doing this. This one's already pretty bright. This one's down at about 6th magnitude right now, 7th magnitude, and it's already showing a tail. It's already gone green. It's got that cyanogen characteristic green to it. It's in the constellation Fornax, but it should be coming up for southern hemisphere or northern hemisphere viewers in the twilight sky after it reaches perihelion here mid-May, looking low down to the area around Sirius. It's going to be in mid to late May. And it's not going to get much brighter than 5th or 6th magnitude, but that's what the comet looks like right now at about 7th magnitude, and it's actually showing a little bit of tail, a little bit of structure there. So these, unfortunately, we don't have a super bright comet coming by. Incidentally, this one was the first one discovered by the MASTER survey, which stands for Mobile Astronomical System of Telescope Robots. That is down in the Southern Observatory in South Africa. And this is the first one that Master discovered, and this is also the first comet discovered from South Africa since 1979. So it's kind of cool.
Will either of these be the comet that the universe owes me?
No, it won't. We're still about every 20 years or so. Unfortunately, they haven't built the magnetic telescope that attracts comets from the old Superman cartoons yet. So once they build that, maybe we can actually we don't want to attract them too close, but we might be able to bring in bright comets a little more.
Because I'm still not over comet ice and fizzling.
Oh, me neither. Well, we're about Hale-Bopp was really one of the last good ones for the northern hemisphere. There was Comet McNaught, but we didn't get as good a view of that up here back in 2006. So like I said, about every 20 years. But what was odd is when we had Hale-Bopp, we had Hyakutake too.
Yeah, which was terrific. So
I actually enjoyed that better because it came out of nowhere. Hale-Bopp we knew about for a year, but those ones that just come up and they're bright within a month or two, that's really exciting when that happens.
Yeah. All right, so Jolene, it's your turn.
Save the best for last.
We saved the best for last. So which one do I want to do? I want to talk about NASA looking for life in Enceladus's plumes.
Okay, yeah, and I think this is actually really, really interesting because when people think about life in our solar system, obviously besides Earth, the first place that people always jump to is Europa. That's one of Jupiter's moons, and the reason that people go there to that planet is because we've known for a long time, or at least we believe, that it has a subsurface ocean. And, of course, where there's water, there's a pretty good chance of life. So people think alien life in our solar system, we go to Europa. The problem, though, with Europa is that if we wanted to actually get down to the subsurface ocean, we'd likely have to drill through kilometers and kilometers of ice, which is a bit of a problem. It would be extremely, extremely difficult, not only technologically, but it would cost, obviously, quite a bit of money to get the technology there in order to actually do this. So with that in mind, a better idea, actually, might be to take a look at Enceladus. And this is one of Saturn's moons, which, again, we also believe has a subsurface ocean. And the notable thing about Enceladus is that the moon has geysers that are actually shooting out into the solar system. So we wouldn't need to go there with all this technology to drill down. Rather, the idea is to first do a flyby mission, which would be something headed supposedly by the Jet Propulsion Laboratory. It's currently called ELF, which is the Enceladus Life Finder. And what this mission would do, they think it could start as soon as next decade, assuming that we actually invest in this. But we could go to Enceladus, do some flybys, and try and find some long-chain organic molecules. And these would sort of be the signals of life. So to be clear, no one's saying that we should go to, or at least most people aren't saying we should go to Enceladus in order to try and find life that's getting, shot out into the solar system, because if it was getting shot out into the solar system, it would probably die once it left the subsurface ocean. What we're actually looking for is the signals of life. And we have a pretty good reason to believe that life actually might exist on Enceladus because it's believed, well, first off, we know Cassini has seen an abundance of organic molecules like carbon and nitrogen. It's also believed that there could be hydrothermal vents if the ocean is making contact with the rocky mantle. And of course, on Earth, where we see hydrothermal vents, we continually find these crazy, crazy extremophiles that are able to exist in just the most ridiculous conditions where you would not expect to find life. So if there actually are hydrothermal vents on Enceladus as a result of all the geothermal activity from the tidal interactions that the moon has with Saturn, there's a pretty good chance, given the various compounds and molecules that we believe are on Enceladus, that life could exist there. So there's that first mission, which would be just the flyby to try and get some samples of the geysers. And then the next one is actually, the abbreviation is LIFE. That's Life Investigations for Enceladus. And this would have maybe a 2030 launch time. Again, that's assuming everything goes right and we actually invest in this project. And this would actually be a return mission. So this would cost a lot more money. The idea being that if we do find these long-chain organic molecules, we would then send a craft to Enceladus to actually collect samples from the geyser, bring it back to Earth, and then conduct analysis here. Personally, I think it'd be pretty awesome if we did that, because, I don't know, I think we could probably all use some good news, and in our solar system would obviously be absolutely fantastic. One problem with this is that if we do find these long-chain organic molecules, there's no guarantee that they're actually produced by something that is something biotic. So if we go there, we take these samples, people could argue that's actually produced by something not biotic. However, it's better than, say, maybe finding evidence of life that once existed on Mars, because if we do find that, as awesome as that would be, the argument then becomes, well, perhaps life on Earth was seeded by Mars, so really life only arose once in our solar system. Whereas if we get out to Enceladus, we find evidence, it's much more likely that life indeed actually did arise on 2 separate locations, on 2 separate bodies in our solar system. So that would be awesome.
And what's the stage of the development of the mission right now? Like, it's just in the initial planning stages, nothing's been approved yet or voted on?
Yeah, but I assume that most of us have heard about all those changes being made to NASA's budget, where apparently we're spending less on Earth sciences, so who knows, maybe some money will get shuffled over there, and some good will come out of it that way anyway.
Yeah, I mean, when I talk to astronomers, planetary astronomers, astrobiologists, and I ask them what they feel is like the best chance for life in the solar system, they often will say it's Europa, but the problem is that life is under 10 kilometers to 100 kilometers of solid ice, and so you have a really hard time getting at it. But isn't it really convenient that we've got Enceladus here blasting this material right out into space that you could just run through like a garden sprinkler, and just collect the samples. So it sounds like a really great way to go about it. Man, we are running out of time. I got so many stories here. All right, let's go with a few more here. Brian, you want to talk a bit about crowdsourcing a comet's trajectory?
Yeah, this is
very quickly, all of you.
Very quickly.
You got like a minute each for each one of these final stories.
Here's the basic idea. You look at a comet like Comet Holmes, and you've got a lot of photographs that have been posted publicly. And so what a team did is they went to Yahoo Search and gathered a whole bunch of photographs from Comet Holmes, and then mapped where it was seen relative to background stars. And really it was a test of how accurate these pictures might be used as data, because they're taken all over the place, they're not cataloged or anything else. And what they got was they got the ability to calculate a trajectory that's within a couple of % of kind of the official JPL ephemeris. And it was just done by amateur astronomy photographs, which is actually really cool that you can get that level of accuracy from just...
If you've ever posted a picture into Flickr, shortly after you post a picture, a robot will come along and tell you exactly where that picture was taken.
Yes.
So
and that's the same type of thing.
Yeah, just awesome.
Yeah.
All right, Charles, let's get an update on X-Core and Virgin Galactic.
There's not a huge amount of news really, but following on from Blue Origin's test flight last week of the new Shepherd suborbital craft, but this week both Virgin Galactic and X-Core have come out with updates. All they essentially say is we're building the spaceships, we're going to start testing later this year, and it seems that they both feel the need to sort of say, hey, look, we're still in the race here. But I think Blue Origin probably took them a little bit by surprise.
Well, Virgin Galactic, even after their disaster last year, has said that they're still planning. Last year they were saying that they would still be doing some tests this year or launching people. Do you think that's still going to happen?
They're still building the second spaceship, which should be, it's about 90% built. They reckon that'll be built by the summer. It's still subject to any modifications. Once the National Transportation Safety Board completes its investigation into the crash, there might be modifications needed to the spacecraft, some hardware, some software. So subject to that, they're sort of saying later this year they'll begin the test flight programs again of Spaceship Two. So how long after that commercial flights might begin will depend entirely on how the testing goes.
Right. And Jolene, you get the last word. I am going to choose the Pulsar with the widest orbit ever discovered.
I'm glad you chose that one because this is probably one of my favorite stories from this week, simply because this pulsar was discovered by a couple of high school students who were participating in the National Science Foundation. It's a summer program where students essentially go and comb through tons and tons of data looking for pulsars. And if they find strong evidence for one, they get to go and meet with astronomers and actually confirm the discovery. And that actually happened. So one of the high school students was quoted as saying, "This just proves that you don't have to be Einstein in order to do science." And I think that's something that we really, really need to hammer home. You don't have to, have some supreme intellect. You just have to be able to make observations and, logical inferences. You can do science. So the news, though, is that this pulsar is in a binary system, which is pretty amazing because when pulsars are created through a supernova explosion, if they are in a binary system, usually they are shot out and they're no longer in binary systems because of the force of the explosion. So not only is it a binary system, it has the widest orbit of any pulsar that we've discovered. I think it's about 52 or 53 million kilometers, which is comparable to how far Mercury orbits from the Sun. And it will really help us understand how pulsars form, specifically how pulsars form with neutron stars in binary systems. So it opens the door for a whole bunch of research, and really it's all thanks to a couple of high school students. So it's pretty awesome.
That's awesome. Okay, so I got a question here that comes from Guido Bibra. He says, I listened to Bill Nye talking about the light sail on Star Talk yesterday. The launch seems to have been postponed because the Air Force is still fiddling with the secret primary payload. There's rumors that it's the X-37B. So does anyone know about this?
It is, yeah. Last I heard, it was May 20th. I don't know if they pushed it back, but it is part of that X-37 payload going up, yes.
And the rumors that we talked about last week was that maybe the X-37 is testing super secret ion propulsion, right?
Well, there's a NASA payload on there. I haven't dug into it very deep, but NASA is testing something on board there as well. I've seen some articles flying around about that, but I don't know what exactly. So it's going to be interesting for us satellite hunters because both light sail and the X-37B are high interest items for ground spotters to chase down.
This question comes from Matt Woods. Is there going to be a mass exodus of orders from the Russian space program to these commercial space programs in the next coming years as the Russians are having some problems and losing spacecraft and rockets? Charles, what do you think? Do you think we're going to have an exodus?
Yeah, well, certainly, obviously, NASA want to put all their contracts for transporting astronauts over to these new cruise ships, which is why they've helped fund for billions of dollars over the last few years these programs. So that's in terms of the people side of things. But of course, Russia are also developing lots of new spacecraft, like they're developing a new human spacecraft, the new Angara rocket as well. So they're investing quite a lot in new technology, and a lot of it survived recent budget cuts and pressures in Russia. In terms of the commercial satellite market, that's getting ever more competitive, isn't it? So Russia will have to be, rather than suffering, everyone needs to get more competitive because there's more and more launches, and even once these sort of commercial suborbital craft get going, that there's the ability to launch small payloads and CubeSats more cheaply. So the market's going to get definitely more competitive, and Russia obviously can't afford to have these sort of problems.
Yeah. Well, we're kind of reaching the end of our time today, so we should probably start wrapping things up. But before we do, I just want to do a big shout out to the WSH crew, which is the Google Plus community that is absolutely instrumental in the creation and maintenance of this show. I know they helped coordinate the special guest, and I think they probably worked with Jolene to get her up to speed on joining us. So again, if you are a fan of the show, do a search on Google for the WSH crew. It's a community on Google+. They're the hardcore fans and really the executive producers of this show. They choose our stories. They choose. They're helping us find the kinds of guests that they want to see on the show. And if you want to be a part of that, then join that community. All right. Well, let's give people a chance to explain more about themselves. So, Brian Koberlein, where do people find out more?
You can find me at briankoberlein.com, where One Universe at a Time is the blog that I have. You can find the One Universe at a Time podcast, which you can also find at From Quarks to Quasars. And I think that's most of it. If you want to support me, you can go to Patreon/Brian Koberlein and kick in a few shekels, and that would be great.
That's great. What's your next reward? What's the next?
It's
gonna be doing?
videos. The next
You're
thing
gonna
is
be doing videos. Excellent.
yeah.
Don't worry, they're easy. Super easy to do. Yeah, you should totally do it.
Yeah.
All right, Charles Black, where do people find out more?
Well, if you love space, you need to go and visit Send.com as one of the sites that you visit. There's lots of great space sites out there, including your own, Fraser Universe Today, of course. But do check out Send.com if you've not seen it before. We're doing space news updates every day, and if you really want to help contribute to some in-depth articles and analysis, become a member. So we've got certain content like expert blogs and features, and original content, and loads of great space data, which is quite a new thing we're doing. So become a member and join us and help contribute to what we're doing would be great. And yeah, and you can follow us on Twitter as well, at Sen. Simple.
Wonderful. Dave Dickinson, where do people find out more?
See, this week I was active on Listosaur, Universe Today. I was active on Sen. I wrote an article for Charles on the anniversary of the launch of Telstar 2. That was a lot of fun to write and research. And I offer up free chapters of science fiction every Friday. There's a new chapter up on my own website, AstroGuys.
Wonderful. All right, Jolene, are you ready to shamelessly self-promote yourself and your website?
I am. And actually, I can shamelessly promote you guys as well, because we continually post articles from Brian. We also frequently share your videos, Universe Today videos, on our website from quarks@quasars.com.
And we appreciate that.
Yes, yes. Well, you're fantastic. So, and we also write our own articles covering news and science and crazy theoretical what-if questions that are totally absurd and ridiculous, but a lot of fun. And I'm always commenting on stuff over at Facebook, on our Facebook page. I spend an absurd amount of time there. So, if you want to get in touch, head over there. It's probably the best way.
Wonderful. You guys are doing a great job. I sort of spotted you coming up on the radar about a year ago and talked to you and your co-founder, and you guys are doing a terrific job of sort of finding that intersection between rigorous space reporting and the kinds of stuff that I think people are really interested in, and I think it's you guys are doing a great job. So I'm really glad you were able to sort of bring someone to join us on the weekly Space Hangout, and definitely feel free to come back anytime. Really appreciate it.
Yeah.
So, of course, I'm Fraser Cain, publisher of Universe Today. There's me on Twitter. We've got a whole new batch of videos coming out. I'm just writing episode 184 now, I think. So we got lots and lots of stuff that we've done. Those come out twice a week. Just subscribe on YouTube, wherever you're watching this, and you'll get a notification twice a week when we do our guide to space, as well as the weekly Space Hangout, which is what you're watching right now. So thanks to everyone that joined us. Thanks to everyone who watched, and special thanks to the Astronomy on Tap folks who are now going back to doing their regular jobs as being astronomers. We really appreciate everyone, and we'll see you all next week.
Bye.